field that we come from, peer-reviewed research is the gold standard. And so we wanted to have the type of evidence chain that will allow us to kind of have proof of concept, show exactly what's happening after proof of concept, and then an outcome-based focus in athletes or other individuals to show what can happen once we're able to take this carnosine, topically apply it, and get it into the body. And at the same time we started to do that, which was in 2015, we also worked diligently on the patent process. We realized that we needed robust patent protection, so we started that process because it does take quite a long time. And in fact, we actually do have two patents, both a medical and a sports performance patent, which myself and Dr. Sharp authored. And so after that, we focused on the research. We started off with the transepidermal 3D skin model, showing just exactly how much of topically applied carnosine and magnesium could go through the dermal layers in comparison to like a placebo vehicle and then just carnosine magnesium by itself. And we took 300% more through the skin than the other two conditions. From there, we followed that up with muscle biopsy studies. We did it both in humans as well as equine and thoroughbred racehorses because of their known high concentration of muscle carnosine. And it is also very difficult to increase muscle carnosine in horses as similar to humans. What we found in that research was after one single application, we saw anywhere from a 50 to a 300% increase from baseline from what was there existing after one application. And so that was universal across the board. That has been published. And from there, we wanted to show, okay, so once we have shown that you can topically apply and deliver it, we know where it's going to end up. What will that look like in terms of human performance? So we started out with a series of studies, both outcome-based. The first one was aerobic and anaerobic. We did 2 arms in elite athletes, elite soccer players from AC Milan, and they did all-out repeated 1,000-meter sprints. And then they also did the intermittent yo-yo test, which is specific to the sport of soccer. We saw up to a 15% improvement during the anaerobic arm, and we saw near statistical significance, a bit arbitrary because we're talking like 1 p006, but there was still, pretty noticeable improvements there that we had not hypothesized. That has since been followed up by independent research as well, from Dr. Marty Bevan and his lab. They studied anaerobic performance in the New Zealand All Blacks Olympic rugby team, the Rugby Sevens, and they saw a similar but more impressive result than what we saw. They did the gold standard of exercise test, which was a Wingate study. They did a repeated Wingate study. They actually did 12 sprints. And in those 12 sprints, they saw an average of 100-watt improvement over the placebo condition. It was a phenomenal improvement, and they did a simulated rest period where they saw a recovery of 145 watts, which was the highest that's ever been recorded in that population in the scientific literature. It actually is triple the previously recorded increases that were documented in those type of athletes, and that is published in Dr. Bevan's study. They also discuss heavily about how this could be a product that could be beneficial for people with low muscle carnosine, such as vegetarians and things of that nature. So that kind of wrapped up the kind of the peer-reviewed research realm. We have another study that is at Journal Now. It's a cramping study where we showed roughly a 60% reduction in cramping daily with the compared to the placebo condition. So that should definitely be published soon. That was also in elite athletes and soccer players, professional soccer players. And so that was kind of the chain of custody for the evidence that we wanted to show, to have a demonstration of what's possible. And then from there, as you know, it kind of pivoted into other areas where we're now